Welcome to your briefing on our plan to colonize Titan. In case you didn't already know, Titan is Saturn's largest moon. Here are some useful pieces of information to aid you on your journey. Titan is approximately 5,000 kilometers in diameter, making it the second largest moon in our solar system. It is also approximately 0.4 times the size of Earth. Titan consists of 5 distinct layers. Firstly, a rocky center surrounded by a layer of Ice 6, which is a type of high pressure ice. This is followed by a liquid layer of water and ammonia, and then a layer of Ice 1H, also known as regular ice. Finally, the surface is made of a sandy substance, likely consisting of organic hydrocarbons, similar to soot that are clumped together due to static electricity buildup. Titan's surface also has cryovolcanoes that erupt lava, consisting of water and ammonia from the liquid layer. Titan's atmosphere is composed mainly of nitrogen, with small amounts of methane and hydrogen. This atmosphere is extremely cold. The average surface temperature is negative 179 degrees Celsius, more than 150 degrees Celsius colder than the North Pole. In order for you to survive on Titan, you will need air, food, water, and shelter. We will now be going into further detail on these aspects.
First, we will need to get to Titan. We will have to transport a lot of equipment and people to begin our colonization of Titan. For takeoff and landing, we will use liquid propellant rockets for vertical takeoff and vertical propulsive landing so that we can reuse the spacecraft. Instead of using one or two large engines, we will increase the reliability of our spacecraft by having multiple smaller engines, allowing the spacecraft to remain safe should multiple engines fail. To make the long journey to and from Titan, we will use a nuclear thermal rocket where liquid hydrogen is heated to a high temperature in a nuclear reactor and then expands through a rocket nozzle to create thrust with much better fuel efficiency. The journey will take around 5 years, so we will put our astronauts into cryosleep to minimize the amounts of food and water required to transport them there. Now that we have arrived on Titan, we can start setting up our base.
First, we need water. There are many cryovolcanoes on Titan. Water and ammonia are brought to Titan's surface by these cryovolcanoes. We will collect this mixture and remove the dissolved ammonia by heating the mixture, causing the water to not be able to hold any more dissolved ammonia. The ammonia gas can then be cooled by allowing it to exchange heat with the atmosphere on the surface of Titan. As the ammonia is cooled below its boiling point, it will condense into a liquid, which can be easily stored for future use as fertilizer. Water will also be recycled from a few sources to reduce the amount of water needed to be obtained from Titan. The air in the living quarters of Titan's inhabitants will be dehumidified, condensing moisture from sweat and breath. Water will also be collected from showers, sinks, and toilets. First, we will filter the water, removing microscopic particles and some bacteria from the water. Then, we will pass the water through a reverse osmosis filter to remove bacteria and unwanted dissolved chemicals. Finally, we will use ultraviolet light to kill any remaining biological contaminants, making the water safe to drink. Water will be recycled with minimal loss, which will be accounted for with water from the cryovolcanoes.
Air is arguably the most important resource required for our survival. Although there are trace amounts of oxygen in Titan's atmosphere, which come from the geysers on another one of Saturn's moons, Enceladus, it will not be enough to provide for our colony on Titan. Oxygen will be generated through electrolysis of water that we have obtained from the cryovolcanoes. Electricity will be passed through the water in order to split it into oxygen and hydrogen using a catalyst to increase the efficiency of the reaction. However, pure oxygen in the living environment is not ideal, as oxygen aids combustion and is an explosion waiting to happen. Titan's atmosphere is 94.2% nitrogen, which we can isolate through pressure swing adsorption technology and use it as a buffer gas to achieve an Earth-like atmosphere of 21% oxygen and 79% nitrogen, allowing for a safe environment.
To achieve all of these, we will need to have a sustainable source of power. Although the winds on the surface of Titan are very slow at 1 meter per second, but at an altitude of 120 kilometers, the wind speed can reach up to 430 kilometers per hour. The high wind speed, combined with the high density of atmosphere on Titan, will allow us to generate large amounts of power. In order to harness these winds at such high altitudes, we can take advantage of the low gravity on Titan. Sails will be used to lift wind turbines up to higher altitudes, and cables will be used to bring the power back down to the surface, as well as anchor the wind turbines in place. To store the generated power for backup, we will be using superconductors in a core. Superconductors are materials that have zero resistance as long as they are cooled below a certain temperature. We will use YBCO superconductors, which have a critical temperature of 93 degrees Kelvin. As the average surface temperature of Titan is 94 degrees Kelvin, we will just need minimal cooling to ensure the superconductor is able to store energy using superconductor magnetic energy storage. This allows for dense and efficient energy storage.
Over here is the kitchen. Humans require 13 vitamins, 16 minerals, 9 amino acids, fats, water and carbohydrates to survive. On Titan, we will be growing chlorella algae, barley, and soya beans to provide us with a sustainable source of these nutrients. Additionally, heme from the root of soy plants will provide food with meat-like flavors. Vitamin D will be obtained by utilizing UVB lamps in certain living areas, as plant sterols can be used in place of cholesterol for the body to generate vitamin D. Potassium and phosphorus will be obtained and recycled through the plants. After the inhabitants' mineral-rich urine is filtered, the residue will be used as fertilizer, allowing the plants to selectively absorb the minerals in the urine. The inhabitants will consume the plants to obtain the minerals.
Oh hey, didn't see you there. Welcome to our home on Titan. Come have a look inside. The surface of Titan is covered in liquid lakes, mostly consisting of methane and ethane. Using this ethane, we can make plastic, or more specifically, polyethylene.
The ethane is cracked, then undergoes a polymerization reaction. Under different conditions, many different forms of polyethylene can be produced.
On Titan, our homes are mostly built out of high-density polyethylene.
With Titan's gravity being a fifth of Earth's, inhabitants will inadvertently suffer from a loss of bone density, also known as osteoporosis, causing bones to become brittle and prone to breaking. Thankfully, there are ways to counter this through a carefully managed diet and special exercises. Increased levels of calcium and vitamin D can be incorporated into diet, while exercise has shown to be able to increase bone density in the areas where force is applied. Exercises such as running while weighted on a treadmill and NASA's Advanced Resistive Exercise device could help strengthen the overall bone strength of our inhabitants and keep osteoporosis at bay.
Thank you very much for your attention. Good luck on your journey. I will see you on Titan.